where all the desktop I'll share so that every screen you can see. Hope the screen is visible now. Is my screen is shared? Okay. So yesterday we were discussing about load store instructions, LDR instruction, that is single registers load store instruction, where you can go for only single register. You are not dealing with single register load store addressing modes. In that one, there are three different types of addressing modes are there. One is the pre-index with write back. Second one is simple pre-index, and the third one is post-index. So there may be a question, theory question with examples. With example, explain the single register load store addressing mode. They will ask you. It will be asked for 6 marks or 8 marks. So generally they will ask, or simply they may ask, explain the load store addressing mode. They may ask you. So you have to be very specific, and with the syntax, with examples, you need to explain that. With example, with syntax, with some one example for each mode, you should explain that. So this is three types which is visible on the screen. Pre-index with write back. So pre-index in the sense, the index will be within the square brackets. Write back in the sense, whatever the new address you are giving, it may be plus or it may be minus, plus or it may be minus. Okay, so it will go to that particular address. It will go to that particular address, and it will take the data from that particular address. It will load that one to the destination register, and hope everything is going on fine. After loading the data which is present in the given address to the destination register, the source register will be pointing to the new address. That is write back. See, write back is clearly, it says that whatever the new address we are given, R1 plus 4, R1 plus 4. So R1 plus 4 will be loaded to your source register. Source register will be pointed to the next memory location. So we will be having the data of that register in the destination, and we will be having the address of that register into the source register. That has been given here example. In pre-index, only pre-index, what happens? It will take the data, but the address will not take to the source register. Post-index, what happens? It will go for the data which is given outside. Okay, means outside we are given, it will take the data, it will be stored over there. See, that is what is being explained here. See, a pre-index with write back calculates an address from the base register plus the address offset. The offset may be positive or offset may be negative. Clearly it is showing, and then updates that address base register with the new address. This is very important. Whatever the base address and plus the offset you are given, that will get updated to the source register. Okay, see here, the source register what we are given in this case. See, I'll once again show you yesterday's example only I'm giving over there. Here what I given, R0 is 0000, R1 is 90,000. Just assume that 90,000 and arithmetic value only will give. Here I given R1 comma #4 with exclamatory, with the exclamatory. What it will do, it will take the R1. R1 is what? R1 is 90000 plus 4. 4 means 90004. The value present in that one will be stored into the destination address. So what is the value present in that one? 0202020202. That will be stored in R0. Then where it is pointing to, it is pointing to 90004. That address will be stored into R1. Previously R1 is 90,000. Now it is going for 90004. So this is what it's going to do. Okay. So memory address will go for it. Now, similarly, when you go for only pre-indexing, if I do only pre-indexing, before that one, it's like this. It's like this. After that, it will go to 9,000. In that 9,000, whatever the data was there, this is the data that will be stored to your R0. It will go to this and it will go for this particular register and +4, and what is there in that one, it will take the address from 9,000 what we are having, it will take and it's going to get the value in that. So R0 will not, as R1 will not change, only R0 is changing. Here R0 is changing, R1 is also changing. In the third case, post indexing, only R1 is changing, R0 will also change, but what happens in the current memory, what is there, that will be given to R0, and the memory is changing here. So three different types we have seen here. So we can execute this, and we can check it out. So there is no problem in that one. But what happens now? We will not be knowing what is the value which is present in that memory address. Junk value we are going to get. We have not stored that, some junk value. We can go for that also. We'll see with the example later. So these are some of the addressing modes where we can go for pre-indexing with immediate offset. I told you immediate offset can be plus or minus here. It can be plus, it can be minus. It can go back to some addresses. I will go ahead with the some address values. It all depends on what is the value given. You may have given 4, you may have given 6, you may have given 8. Generally, it should be in terms of multiples of 4, because 4 bytes. Each memory is of 4 bytes, 32-bit, 32-bit, only you have to use the multiples over there. So example 3.15 uses pre-index method. This example shows how each indexing method affects the address held in register R1 as well as the data loaded in the register R0. That's why register, the address will be in R1 and the data will be in R0 itself. So whenever you are going for the real-time application, when you are using the array, at that time in the array, you are going to use the those index values. We can check it out. Those index values we can check and we can say this is how it's going to work. So here they have mentioned the signed offset or the register is denoted by plus or minus. That means identifies that it is either a positive or a negative offset from the base address register Rn. That's what I'm saying. It may go to the previous address, it may go to the next address also. Previous index or next index, or how much our index you are given, that much. Immediate means the address is calculated using the base address register and a 12-bit offset encoded in the instruction. Register means the register address is calculated using the base register and the specific register counts. Assume that one R1, R2 I given. R2 means some value, that much offset is going to take. So these operations cannot use the barrel shifter. They cannot go for barrel shifter because they are not doing any changes in the data. Only address it is calculating. Barrel shifter is not going to be used. There are no STR-SB and STR-SH instructions, since STR-H stores both a signed and unsigned half word. Similarly, STR-B stores signed and unsigned bytes. So here we are not using STR-S and STR-S. Okay, we are going to use only STR, LDR only. We are not going to use STR-H or STR-B, LDR-H and LDR-B we are not going to use over there. Now, our question will be, if it is more than one register to be loaded or more than one register to be stored, how exactly we can go? Load store multiple instructions can transfer multiple register between memory and the processor in a single instruction. Say, as we have discussed long back, single instruction may use one cycle, but sometimes if we are using the multiple registers in a single instruction, it will go for more than one cycle also. It will go for more than one cycle. Here, we are going to use the multiple register in a single instruction. So it will efficiency will be, means time consumption will be less, and reduced instruction also comes into picture. Number of instructions will be reduced, and efficiency also increases over there. Faster, throughput will be high. The transfer occurs from a base address register Rn memory, pointing into memory. The multiple register transfer instructions are more efficient. See, more efficient from a single register transfer for moving blocks of data around memory and saving and restoring context and stacks. See, whenever you want to get it from stack, multiple registers can be directly, you can get from the stack and multiply, and you can get it back to multiple registers. Similarly, when you want to for the memory, multiple data directly can access from the memory and multiple registers can be stored. So in one single instruction, more data can be transferred. That is the advantage of this multiple register transfer. See, examples they are given. LDR, R0, R1 comma 0x4. This is pre-index with write back. It's been given. Here you see we are given multiple examples of LDR instruction is a different addressing mode. That is STR we have given, LDR also we have given. This is a single store, actually single register it's going to be. Now there are different ways of pre-index and post-index. The same thing which has been given in the other page, the same thing has been given here. When we go for multiple instruction, you have to go for multiple instruction somewhere. LDM, load multiple register. This is what we have to discuss. See, in this page, different types of single register instruction only they are given. LDR, STR, all those things they are given over there. LDR also, STR also they are given. Now our discussion is more to load store multiple instruction. Load store multiple instruction can be the interrupt latency. There may be an interrupt. Because multiple register we are handling and we are dealing with the memory also. There may be a chances of interrupt. So latency will increase. ARM implementations do not usually interrupt instruction while they are executing. For example, in ARM 7, a load multiple instruction takes 2 plus NT cycle. N is number of registers. Okay, N is number of register. T means the number of cycles required for each sequential access to the memory. So generally 2 plus NT. How many registers you are having? That many registers into how much cycles are required for each register movement or a transfer. That will take the time. If an interrupt has been raised, somebody